stuff. Okay, so this part I hope you got from what I said, but so I'm going to go quickly. 2.2 is now 1 to 25 odd. I know I botched this up completely. 2.3, it used to be 1 to 21 odd, but we're skipping a whole bunch, 7 through 19. I sent that last week. Hopefully you got it, but if not, here it is again. Okay, so we're trying to keep along with the schedule. 2.5, I'm changing it to 19 to 39. I think it used to be 15 to 39. It's now 19 to 39, 2.5. Okay, so 2.3 had very little. Okay, so in theory, I gave you enough of 2.2 and 2.3 to do all the work. You know, I'll lecture with 2.4, but about time I'm going to go back. Okay, and I'm going to go and show you some pictures from the book because, as I said, some of you don't have the book and you never got it, and I didn't get a chance to do that last week. So I'm going to try to run through that somewhat rapidly and little mini lecture along the way. Okay, so 2.1, page 84. I know there's no homework problems, but these concepts, and I just alluded to it on an email or announcement that I gave you before. If you replace f of x with f parentheses x plus c, that's a shift to the left by c units. C is a real number. Here's a picture. If it's f parentheses x minus c, that's c units to the right. Okay, so the blue was the original and the red is the change. If it looks like this, f of x plus c, the plus c is not part of the parentheses, that's moving up c units. And f of x minus c, you go down c units. Okay, so that was 2.1. And 2.2, I tried to show some of this for you, but the absolute value function, it's V-shaped, so it looks like this. Here's a formal definition of the absolute value function also, but just think of it like this. And here are some changes you can make to it, right? So the blue on page 86, the blue is the absolute value. If you put a 2 in front, 2 absolute value of x, it becomes steeper. Here's how you can move it. So absolute value of 2x minus 1, that moves 1 unit to the right. Okay, and if you put a negative in front, it's going to make it go down. Right, so that's something quickly about that. Okay, example 3, again on page 86. This is what happens if you have the absolute value of a function. So here's the graph of x squared minus 4x plus 3. Okay, if you put absolute value, you know there's not going to be any graph below the x-axis, because down here, that means there's negative y values. Okay, so everything that's above stays the same. So see that part? It's exactly the same over here. But this part that's down below, that part down here gets reflected across the x-axis, so it bounces over there like this. So that's what happens when you have absolute value of a function. So it goes like this. That stays the same. That stays the same. This thing gets bounced over. Okay, I know I'm going somewhat quickly because hopefully you got a chance to look at the thing I gave you last week. Again, I hope you were not thinking last week was a holiday or vacation. You know, we couldn't do that. Okay, square root function. So you should know quickly, square root function looks something like this. 0, 0, 1, 1, 4, 2, 9, 3, looks something like this. Here's an absolute value that got moved. Okay, so square root of x minus 2 minus 1, that moves 2 to the right and 1 down. So the origin got moved to 2, negative 1, and you just draw the same general shape. Okay, and then an interesting function, page 89, the greatest integer function. Okay, so you either write it like that or with brackets. Okay, the greatest integer function always rounds down to the next lowest integer if you don't already have an integer. Okay, so here's some examples. Greatest integer function of 1.2 is 1. Greatest integer function of negative 1.5 is negative 2, not negative 1. Going down would be negative 2. Greatest integer of 2 stays at 2. It's already an integer. Greatest integer value of 0.33 is 0. So you always go down. Here's what it looks like. It's called a step function because you kind of looks like you're stepping up values. See here it has the origin, right? So 0, 0, 1, 1, 2, 2, negative 1, and so on. But notice here, if you have 0.1, 0.2, 0.3, all the way up to 0.999999, any of those would be rounded down to 0 by the greatest integer function. And then once you reach 1, you jump up, and same thing applies all the way through. So that's the greatest integer function, quickly. Okay, and I'll quickly show you the problem. So page 91. So in case you never got that, so there's that, and a little bit lower. Okay, and again, you can always play back later. And some more on next page. Goes up to, I guess, 41. I'm not sure we even have to go that far, but there's that. Okay, and then 2.3, which was now going to be a very short lesson, page 93. Adding, subtracting, multiplying, dividing functions. It's, you just add them, you just subtract them, you just multiply them, you just divide them. That's basically it. Okay, and you don't need to know any of this. Then for the problems, so page 100, 2.3, there's that. Okay, so you've got that on the recording. And then over here, we are throwing out all of these guys, so forget about that. The only other one was 21, so here's 21. Okay, 2.4, which we're starting today, composition of functions. Okay, well, there's nothing really you need to know here, but yeah, I'll just lecture when I get started on that, but I do want to at least show you the problems again. So 2.4, page 109. Okay, so there's part of it, and some more. So hopefully that's enough that you can rewind or fast forward. 2.5, page 110. There again, I'm not sure if we need all of these. And some more there. All right, and then 2.5. While we're at it, might as well just go ahead and give you the whole works. All right. So we're still planning to have a test on Friday, the next test. Okay, and let's see. One-to-one function. So on page 112, one-to-one function. Again, feel free to start building up your next cheat sheet. Okay, page 113, the horizontal line test. You heard of the vertical line test, so now we have the horizontal line test for one-to-one functions. And inverse functions, so everything you need about inverse functions right here. Okay, put whatever you want on your cheat sheet. And let's see, page 116, determining the inverse of a function. There's the procedure. I'll go over all of these. And the graph of the inverse function. Okay, so there's that. And that should be enough of that. Okay, and then the homework problem. So 2.5, this is where? Page 119, it looks like. Okay, so that should be that. That should give you enough. Then on the next page, that, and a little bit more, and that should do it. Okay, so there we go. All right, so if I look at the schedule, I'm hoping for 2-4 today and tomorrow, Wednesday and Thursday 2-5. Next exam is Friday. By the way, if you didn't catch my email, we were supposed to have a quiz on Friday. Everybody got 5 points on a non-existing quiz. Okay? So, you know, I had my spreadsheet all set up for all your quizzes. So the only fair thing for me to do is give everybody a 5. So everybody automatically got 5 points in the quiz. You didn't have to do anything, and you got 5 points in quiz 3. Okay, good deal on that. But we're aiming for the next test on chapter 2 this coming Friday. Okay, so here we go with 2.4 now. Okay. The topic is composition of functions. You have a function of another function. Right, so composition of functions, you have a function of a function. So you're going to see something that looks like this. F circle G, almost looks like fog. We say F circle G of X. It means F of G of X. So you have a function of another function. See, when you normally write a function like this, right? F parentheses, parentheses. So behind my pen here, you normally expect something like 2 or 5 or pi or something like that. Well, you're allowed to put another function. Right? So you have a function of a function. We say F of G of X. You could switch it around. See G circle F of X, which is G of F of X. You could even have f of x, f circle f of x. Okay, and just hasten to add, you might think, well, if I do the f of g or g of f, do I get the same thing? In other words, is composition of functions commutative, meaning can I turn them around? Okay, there's something called a commutative property. You might recall that addition is commutative and multiplication is commutative, but is composition commutative? In general, no. If you do f of g of x, it's not always the same as g of f of x. It might be the same sometimes, but in general, it's not. Okay, so let's get started with some of this stuff. So for problems 1 through 6, they give you f of x is 2x minus 3, g of x is x squared plus 2. Okay, so first they say f circle g, looks like fog of 3. It means f of g of 3. Okay, so what you do is you do the innermost parentheses first. So first forget about the f, forget about anything besides the g of 3. Okay, so I see g of 3, right? So take that 3 and put it right in here. So we have 3 squared, which is 9. 9 plus 2 is 11. Okay, so this thing right here, g of 3 is 11. Because when I put 3 right here, 3 squared is 9. 9 plus 2 is 11. So I have 11. So now, instead of writing all this junk here, I'm going to do f of 11. Okay, and now 11 goes into the function f. So in other words, you're doing one function and you're immediately doing the other function. So now 11 goes right here. 2 times 11, 22, minus 3 is 19. Okay, so the answer is 19 for this particular problem. Right? So you just do the inside function first, and then you take that answer and then it goes into the function f. Okay. Now, g circle f looks like golf of f of 3. That means g of f of 3. So this time I do f of 3 first. So by order of operations, I do that first, the f of 3. Okay, so 3 goes right into here. Okay, so I put a 3 there. 2 times 3 minus 3. Well, 2 times 3 is 6. 6 minus 3 is 3. Okay, so I know that this thing in here turns out to be 3. And now I take that answer of 3 and apply it to the function g. So 3 goes right there. 3 squared is 9. 9 plus 2 is 11. We just did that. So the answer is 11. Okay, and I was just emphasizing right here, notice they are not equal. The equal sign with a slash means not equal. So they are not equal, as you can tell. Okay. All right, so f of g of negative 3 is what's asked for here. So f of g of negative 3. So I put negative 3 right here. You do the inside function first, negative 3. So negative 3 squared is 9. 9 plus 2 is 11. So once again, you get 11, and then you plug in 11 here. Well, we just did that. You get the same thing, which is 19. So f of g of negative 3 is 19. Okay, now, you can apply a function to itself, f of f, or g of g. So when it says f circle f of negative 2, so we're using this function twice. We're ignoring g. So for this part, we're not going to do g at all. We're only looking at this. Okay, so f circle f of negative 2 means f of negative 2. So first I figure out f of negative 2. Okay, in my notes here I say negative 7. How do I get negative 7? Okay, put negative 2 right there. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. Okay, so this thing right in here is now negative 7. So that's negative 7. I now apply that, negative 7, back to the same function since it's f. So negative 7 goes right back to the same function. 2 times negative 7 is negative 14. Negative 14 minus 3 is negative 17. So it looks like the answer is negative 17 this time. Okay, so there we go. That's the way that one works. Okay, jump over to number 7. 7, here are the two functions. F of x is 2x plus 1. G of x is 3x minus 1. And they want fog and golf again. F circle g, g circle f. Okay, so f of g of x. This time we're not plugging in a number. We're coming back with another function. Okay, so I'm saying, how do I do that? So fog, f circle g means f of g of x. So what I do in the next step, okay, see where it says g of x right here? Instead of writing g of x, I'm going to write what it's equal to. So what is g of x equal to? 3x minus 1. Okay, so the next step, I'm going to put f paren 3x minus 1 paren. So it looks like this. So you notice this g of x, I replace it with this because they're equal. It says so right over here. And now this mess, maybe I'll cover it up. Whatever's behind my blue pen goes in for F. So that expression goes right over here. 2 times whatever's behind my pen plus 1 in parentheses. So here we go. 2 times 3x minus 1 plus 1. Okay. And I just work it out. That's 6x minus 2 plus 1. Well, minus 2 plus 1 is minus 1. So 6x minus 1. By the way, you'll see me do this maybe a little bit more. And that means if I do it, I'm going to let you do it also. It should not be that bad for you folks to say, oh yeah, 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. I can go straight to that. You don't have to say 6x minus 2 plus 1 and take another step to write that. Now, if you want to do that, I'll let you. But that should not be that hard to jump straight from negative 2 plus 1 to negative 1. Okay, let's do G circle f of x. Reverse it. So G of f of x. Okay, so the first step is instead of writing f of x, I write down what it's equal to. What it's equal to is 2x plus 1. So I want G of 2x plus 1 right here. G of 2x plus 1. I'm going to cover it up. I mean, you don't have to cover it up, obviously, for yourself, but just for teaching purposes, I'm covering it up. And now whatever's behind my pen goes right there. Okay, so, I mean, if that bothers you, think easy. Suppose behind this blue pen was 0. You would put a 0 right here, right? If behind my blue pen was 1,000,000, you put 1,000,000 right there. If behind my pen was W, you put a W right there. If behind my pen is a mess, the mess goes right here. Well, I do have a mess. It's parentheses 2x plus 1. So I go 3 parentheses 2x plus 1 minus 1. Okay? And once again, shortcut, 6x plus 3 minus 1. Right? Plus 3 minus 1. I'll go straight to 6x plus 2. All right, so hopefully that wasn't too bad. It asks for the domain. The domain for both of them is all real numbers. If you look at this expression for f circle G, there's no problem here, no problem here, no problem there, no problem there, right? Any real number, you can multiply it, you can subtract it, so all real numbers. We're not dividing by anything, there's no square roots or anything like that. Okay, so we might have trouble with some future ones, so let's take a look where that might happen. Okay, so question 9. Here are the two functions, f of x and g of x. Okay, so 1 over x, x squared plus 2x. So f of g, fog, f circle g of x. So f of, I don't write g of x, I write what it's equal to, x squared plus 2x. And now what does f do? F just goes 1 over whatever. So whatever is behind my blue pen here, it's 1 over that. So there it is, 1 over that. Okay, so that's that. It does ask for the domain. So let's talk about domain again. Remember, we're not allowed to divide by 0. Excuse me. Not allowed to divide by 0. So I set the denominator equal to 0, a little bit of algebra. Factor out an x. X times x plus 2 equals 0. That gives me x is equal to 0 or x is equal to negative 2. And that's what gets thrown out of my domain, right? So the domain is all real numbers minus the set consisting of 0 and negative 2. Because if I plug in 0, I get 0 in the bottom. Can't do that. If I plug in negative 2, I also get negative 2 in the bottom. Can't do that. But anything else is fine. Then G circle F, golf, that's G of f of x. So first I put G, paren, and instead of writing f of x, I write what it's equal to. What was it equal to? 1 over x. Okay. And now, let me cover it again. Whatever's behind my blue pen goes right there in parentheses and right there in parentheses. So it's parentheses 1 over x squared plus 2 times 1 over x. So that gives me 1 over x squared plus 2 over x. Common denominator be x squared. So I multiply top and bottom here by x. 1 plus 2x over x squared. Okay, and this time the only thing that's not allowed is 0. So the domain is all real numbers besides 0. Or we can write minus a set consisting of 0. Okay. All right, then number 11 is a little bit harder because it's the square roots. It's a little bit tougher. So 11, f of x is square root of x minus 1. G of x is x squared minus 3. So fog, f circle g of x, f of g of x. So f of parentheses, next step, don't write g of x, write what it's equal to. Well, it's x squared minus 3. Okay, and now that thing behind the blue pen goes right in here, right? So the mess behind my pen goes right there. So x squared minus 3 minus 1, and that comes out to be the square root of x squared minus 4. Okay, so here's the composition, we would say, composition of functions. Since there's a square root, we know the square root of anything has to be greater than or equal to 0. So the thing behind my pen here, I set it to be greater than or equal to 0. Okay, so we've played that game before. Factorize x plus 2, x minus 2 greater than or equal to 0. That gives me x plus 2, x minus 2 greater than or equal to 0. So x equals negative 2 or positive 2 are my boundary numbers. So I lay down negative 2, I lay down 2. They are both closed circles, because if I plug in negative 2 here and here, negative 2 here, negative 2 plus 2 is 0. 0 times that is 0. 0 is greater than or equal to 0. That's true. Likewise, if I plug in 2 here and 2 here, 2 here makes that 2 minus 2, which is 0. 0 times that is 0. 0 is greater than or equal to 0. That's also true. So they're both closed circles. Had this not had the line underneath it, they would both be open. And then I play this game again. Okay, so at the moment, we don't know that anything is shaded. I've already done it before, of course, so you know, the cat's already out of the bag, but pretend you don't know. So I plug in something from region 1, negative 3. Something in region 2, 0. Something in region 3, 3. Do my sign analysis, sign chart. Negative 3 plus 2, negative. Negative 3 minus 2, negative. Negative times a negative is positive. Is the positive greater than or equal to 0? Yes, that's true. Shade in region 1. Region 2, 0. 0 plus 2, positive. 0 minus 2, negative. Positive times a negative is negative. Negative greater than or equal to 0? No, that's false. So do not shade in region 2. Region 3, 3 plus 2, positive. 3 minus 2, positive. Positive times a positive is positive. Positive greater than or equal to 0, that's true. Shade in region 3. So my domain is parenthesis, negative infinity, comma, negative 2, bracket. Bracket means you're including the negative 2. U for union, union bracket 2, comma, infinity. Remember, negative infinity is always on the left. Positive infinity is always on the right. Negative infinity means you're going forever to the left. And positive infinity means you're going forever to the right. And they always use parentheses. Okay, let's reverse it. G circle F means G of f of x. Okay, so what was f of x? F of x way back up here, which is square root of x minus 1. Okay, this is a key point. I'm going to come back to that in a second. But I have the square root of x minus 1. Okay. And now whatever's behind my pen goes into G, x squared minus 3. Okay, so whatever's behind my pen, that mess, blah, 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 right there, I square it and subtract 3. Okay, so here it is. That thing got squared minus 3. Okay. But I have a square root squared. So what happens when you have a square root squared? You just take off the square root. So it's x minus 1 minus 3, which is x minus 4. Okay, now the domains are kind of a question mark. Your first guess might be, is the domain all real numbers? Because if you look at the answer, x minus 4, I can do anything with x minus 4. But the answer is no, because back up at this step, right? When I plug in right here, I have to make sure, since it's a square root, that this thing is greater than or equal to 0. So for instance, I'm not allowed to plug in 0, if you notice, right? So I still have to say x minus 1 is greater than or equal to 0, which means x is greater than or equal to 1. So the domain is actually bracket 1 to infinity. So there we go with that. Okay, now I actually have more from 2.4, but I'm going to stop there for a moment. What time is it? About 9:40. Okay, so to make things a little bit better for you, Because some of you said I couldn't get any of the stuff that you gave last week, and I typed some stuff up, and I did my little mini video on my cell phone, and that may not have been that good. So I've got some notes from before, so let me go back and try to. I gave you some of these also. So the square root function. Okay, so this is the first time that I'm sort of lecturing, quote unquote, live to you. I know I typed it up for you, and I did a little mini video, but it's not quite the same. But to come up with the square root function, I picked these points, 0, 1, 4, 9, 16. Why did I pick those x values? Because they come up with nice square roots, right? Notice I didn't put 2 or 3 or 5. They don't come out nice. But these come out nice, right? Because the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. If you plot it, it looks like that. Okay. All right, then let me go back and talk a little bit more about the greatest integer function. Okay, and I know I gave you notes about it, but here we are live, I suppose. So it can be written either this way or this way. I actually like this a little bit better. And besides, you can type that on your computer keyboard, right? I don't think there's any button for that. Okay, the greatest integer function. If you already have an integer, which means one of these numbers. So you say, what's an integer? 0, 1, 2, 3, 4, and they're negatives. Okay, there's no fractions and no decimals. Okay, then it just stays the same. If you don't have an integer, that means there's a fraction or a decimal part. You always round down. You don't round up, you always round down. Okay, so what I was trying to show you was greatest integer function of 3 is 3. Greatest integer function of -4 is still -4. Okay, they're already integers. But if you have any fraction or decimal, you always go down. So greatest integer function of 3.8 is 3. Greatest integer function of -2.7 is -3. Greatest integer function of 5 and 99/100ths. I especially put this to emphasize you always go down. You might say, oh yeah, 6 is rounded off. It doesn't matter that it's closer to 6. The greatest integer function always goes down, so this has to be 5. Okay? Greatest integer function of -pi. -pi is like -3.141 and so on. That would be -4. All right, and then back to 2.2, quickly about the graph. Okay, absolute value of x minus 4. So absolute value of x looks like this. You should know that. If you're not comfortable with it, put it on your cheat sheet for Friday's test. And then I'm replacing x with x minus 4, like that. That moves the graph 4 units to the right. Okay, and the easiest way I think to graph it is, this is 0, 0, right? Move it 4 to the right, and you're 4, 0. So I put a dot at 4, 0 and just graph the same thing, V shape. Okay? We sometimes use the word translate. You translate 4 units to the right. And by the way, notice what happens when you plug in 4. What do you get when you plug in 4? 4 minus 4 is 0. Absolute value of 0 is 0. So that seems to work. Okay, so the English word translate, I know usually we think of translate like translating a language, okay, but you can look it up in a dictionary. One of the dictionary definitions of translate is to move. Move something left or right or up or down. That also means to translate. And here's another one that I tried to show you. F of x equals absolute value of x plus 2 minus 2. So we have our standard absolute value function. Now, when it's like this, absolute value of x plus 2, that means shift 2 to the left. The minus 2 here outside means you shift 2 down. So you go 2 left, 2 down. Again, the easiest way I can think of is start with the origin. 0, 0 gets shifted 2 left and 2 down. That's -2, -2. So there it is. And then I just draw my V shape as before. Okay. So I wanted to show you some of that. Okay, and then quickly do some other stuff from 2.2. I know I kind of gave it to you before, but I'm trying to go a little bit fast here. So 2.2, for absolute value of x, again, your V shape. If you put a 2 in front, 2 absolute value of x, it becomes steeper. So see this V right here? This one is steeper than the original one. Okay. And here's the one where there's a -2. This green one that goes down, it's a reflection of this one across the x-axis. So 2 absolute value of x is this one. -2 absolute value of x is that one. And that's what I'm trying to write all the way down here. So that's what I was indicating by that arrow. Okay, 7, -3, absolute value x minus 1 plus 1. So what I was trying to show you here, your basic absolute value function, V shape, looks like that. Now, the red one here, if you put a -3 in front, it makes it go down and it's steeper. So see how I made it steeper and going down? And then this means 1 to the right, and that means 1 up. Okay, I know this is counterintuitive. It's against your intuition. X minus 1, you might think that's going to be 1 to the left, but it isn't. It's 1 to the right and 1 up. So I take that red graph, move the origin 1 to the right, 1 up, and then I just draw the same thing. So I go like so. Okay. And then let's see, negative square root of x plus 2. Here's that progression. So you should start with the basic square root function, which looks like that. Then square root of x plus 2. So x got replaced by x plus 2. That moves the graph 2 to the left. Okay, not to the right, to the left. So 0, 0 becomes -2, 0. So it's right there. By the way, one way you can double check, what happens when you plug in -2 here? You get 0, right? -2 plus 2 is 0. Square root of 0 is 0. But if you had moved it 2 to the right, and then if you plugged in 2, you'll notice that you don't get 0. And then the minus in front of the number means all the numbers that were positive now become negative. So that just reflects across the x-axis once again, right? So here's square root of x plus 2, the red one. And then the green one is what happens when you put a minus. It just goes down like so. Okay, then I wanted to show you this one right here. How does f of negative x compare to f of x? Okay. F of negative x reflects f of x across the y-axis. So let's pretend this is the original f of x. Then f of negative x looks like that. Okay, now I'm going to try to show you here. G of x equals square root of 2 minus x minus 1. I got it over here also. It's a little bit tricky. The way you have to think of that is 2 minus x is negative parentheses x minus 2. Right, so here's the progression that I showed you for this graph. I took my regular square root of x minus 2. That moves the graph 2 to the right. And then the negative in front of the whole thing reflects across the y-axis. So you reflect this one across the y-axis, and you get supposedly the red one. So that's now negative parentheses x minus 2, which is the same as 2 minus x. That's the reason why I did all that algebra, to show you that this really is this over here. And then the minus 1 just throws the whole graph down 1 unit. So the green is the final answer. Okay, so one more time, square root of x minus 2, move 2 to the right. Negative parentheses x minus 2, reflect across the y-axis, and then down 1 unit. Okay, and then for 19 and 23, I wanted to show you what happens when you have absolute value of a graph, as we said before. Okay, so f of x equals 2x minus 3. So that's like y equals mx plus b. Slope is 2, y-intercept of -3. So I go down -3 over 1 up 2. So it looks like this. And now if you want the absolute value of f, so for the absolute value, you leave anything that's above the x-axis alone. So this part here stays the same. But anything that's below the x-axis, that gets reflected, okay? Which makes sense. Anything that used to be negative, like -3, right? Here's -3. When you take the absolute value, it becomes positive 3, it jumps over to here. So you reflect the bottom part across the x-axis. So that thing bounces over to here. And notice it is kind of V-shaped, which makes sense because absolute value graphs are generally V-shaped. Okay, and here's another one. F of x equals negative parentheses x minus 1 squared plus 1. Okay, so the original graph was like this. So here's the original graph. It's a parabola. And anything that was above the x-axis stays the same. So this stays the same, that stays the same. But anything that was below, this part's below, right? So we're going to bounce that mirror image and make it come up to here. Okay. All right, then some domain and range questions. 13. Let's see. We'll just look at the graph. So the green is the final graph. So only looking at the graph, what's the domain? Well, I'm going from -2 out to infinity. And the range, you can go as far down as you want, but the highest y value is 0. So parentheses, -infinity, comma, 0 bracket. And then 15 asks for the domain and range also. So 15 was up here. So x, it can go as far to the left as you want, so -infinity, but the furthest right is -2, including -2. So the domain would be parenthesis, -infinity, comma, -2 bracket. And for the range, so this green graph, it goes as high as you want. The lowest is -1. So the range is from -1 to infinity right there. Okay. All right, so I wanted to give you at least that before I go on and see if I can do some more. All right, so going back to 2.4, I took a little time out to, I want to make sure I get some other stuff in, but see what time is it, about 10 to? Okay, but if I can sneak in a little bit more, I'll do that. And then if I have time to go back to previous problems, I'll do some more of that again. So page 109, 2.4, number 13, here's f and g. So it asks for f of g of x, which is f parentheses g of x. Okay, so that's f of what is g of x? 1 over x plus 1. So I put 1 over x plus 1 here. All right, and now I apply that to f. So this thing goes right here. So it's 1 over that. 1 over x plus 1. Which means I'm dividing by a fraction. That looks bad. 1 over x plus 1. But recall, if you divide by a fraction, you multiply by the reciprocal. So it's 1 times x plus 1 over 1, which is x plus 1. Okay. And again, at first glance, you might think x plus 1, oh yeah, domain is all real numbers, but it's a little bit tricky because right back over here, okay, you're not allowed to plug in what number? -1. -1 is not allowed right here. It is allowed here, but it's not allowed by the rules of the game right here. So the rules of the game are you're doing f of g of x, and since I'm doing g of x right here, you're not allowed to plug in -1. Okay, so I have to actually throw out -1. So the domain is all real numbers minus the set consisting of -1. Okay, so that's what I want. Okay, and then g circle f. That means g of f of x. So what is f of x? 1 over x. Okay, so I do g of 1 over x. So see right here where it says g of f? I replace f of x with 1 over x. And now that 1 over x goes right over here. It's going to look bad. But if I erase this, put 1 over x, it looks like this. 1 over x plus 1. Okay? And we should clean it up. And by the way, right now you can tell you're not allowed to plug in 0, right? 0 is not allowed by the rules of the game. Okay, so I have to throw that out. Now clean it up by multiplying top and bottom by x. It just makes it look nicer. So the top becomes 1 times x, which is x. The bottom is 1 over x times x is 1 plus x. All right, and what's not allowed here? -1. So x over 1 plus x, domain is all real numbers minus the set consisting of -1 and 0. So that's what I want for that answer right there. Okay. All right, then for problem 15 and 17, there's really not much to it. It just asks to come up with 2 functions. Let me see if I can find you what the wording is. Find functions f and g such that h equals f circle g. So you come up with the functions. You can kind of look at it and it sort of tells you what to do. All right, so you want the final answer to be this. So one function would be raising something to the fourth power, x to the fourth, and then the other function is this one. Now, which one comes first? Well, the outer function is f, because we're doing f circle g, right? So f is the outside function. So the outer function is raising something to the fourth power. So f of x equals x to the fourth, and g of x equals 3x squared minus 2. So outer function, inner function, outside, inside. Okay? There's two things going on. You've got the inside function, 3x squared minus 2. That's going to be my g if I'm doing fog. And then I'm raising something to the fourth power, x to the fourth. That's going to be f. Okay? And you can double check. If I apply the fog, f of g of x, I'm doing f of 3x minus 2. Okay, so it's f of 3x minus 2. And what am I doing to whatever is behind my pen? I'm raising it to the fourth power. So blah, blah, blah to the fourth power. And that's exactly what I have over here. Okay, so that's all. So you're just coming up with the functions that, give you what you need. Okay, here's our 17. H of x equals cube root of x minus 4. Okay, so one function is the cube root function. The other function is x minus 4. The outside function is the cube root function. So that should be my f of x, cube root of x. Inside function is x minus 4. So there's f and there's g. Okay, and a quick double check. F circle g of x, f of g of x. G of x is x minus 4, so I'm doing f of x minus 4. And what does f do? F takes the cube root of whatever's behind my blue pen here. So cube root of x minus 4. And there we go. Okay, and I think that's more than enough for today since I was trying to do the lesson and kind of going back also. All right, so let me stop the share and check the chat. And I see there's nothing in the chat. Okay, so, all right, so I'll let you ask questions, and if you don't, we can stop. Since, I did a lot, I know we haven't met in a week. But so we're still on track to take the test on Friday. I tried to give you all I could last week, and I tried to do a little bit more today, and hopefully that'll be enough. So tomorrow I'll try to do some more of section 4 and maybe start some of section 5, but we're still on track to take the test on Friday, okay? So anybody have a question, please? Otherwise, we're done. Let me check the chat. The chat has, it's just, oh, I can't hear you, I can't hear you. Now I can hear you, yes, yes, no. Okay. So that's that, my bad. All right, anybody with any questions? All right, I think we're good. All right, folks, so that's it. Looks like we're back to normal, quote unquote. So have a good day, and we'll see you all tomorrow. All right, bye, everybody. Have a good day.